Hey everybody, it's Miss Sullivan, and this time we're talking about multiplication of fractions. So thinking back to last term and having a quick little reminder about BibMaths again, we've just looked at addition and subtraction and remembered that in the context of algebra we needed to find like terms, and in the context of fractions we needed to create common denominators, so making them into like terms that you can deal with. When it comes to division and multiplication, again like algebra, you don't need to find like terms. Algebra had its own rules. It had index laws. So if we remember 2a times 2b, we're allowed to multiply the coefficients together and then multiply the variables together. 4ab, because it's multiplication. Something like this, we're allowed to go, we know there's an invisible 1 here. So again, multiply our coefficients together. 3 times 1 is 3. And then we have a squared and a cubed. Same base, so we're allowed to add the indexes because we're multiplying. 3, a to the power of 5. Then here, when we know this line really means division, and we get 4a to the power of 4 divided by 2a to the power of 2, we simplified. 2 goes into 1 once, 2 goes into 4 twice. We simplified our fraction, and then we were able to, same base, different index, just minus our index numbers for dividing. So 4 minus 2 is a to the power of 2 over the top of 1. So we know that's really 2a squared. So very much like how we're working left to right, we're able to join ideas together. Same deal when we're multiplying and dividing fractions. But before we get into it, super quick reminder again, proper fractions, little numerator, big denominator, something like 2/3. You know it's going to be less than 1. It's going to fall somewhere between 0 and 1. Improper fractions, where my numerator is bigger than my denominator, something like 4/3. And we know that 4/3 can be expressed as a mixed number. Again, because 4 over 3, that overline there, means 4 divided by 3. So 3 into 4 goes once, remainder 1/3. So the mixed number 1 1/3 is the same as 4 over 3. So when we're working with mixed numbers, just like with addition and subtraction, we have to convert mixed numbers back into improper fractions to make them easier to deal with. Sorry, I'm just making that a bit lighter. So let's have a little look at something like, just to remind ourselves of that simplification process again, let's look at something like 20 over 16. So 20/16. We can see that that is a mixed number. We can see that that is an improper fraction. So it can turn into a mixed number. But let's have a little look here. They've got a common factor, which is 2. So we can divide both of them by 2. 2 goes into 20 10 times. Oh, and 2 goes into 16 8 times. Oh, look, we could do it again. Both of these are divisible by 2. So 2 goes into 10 5 times, and 2 goes into 8 4 times. 5 divided by 4, we know that 4 goes into 5 1 time with 1 little fourth left over. So while it would be quicker to know that these were both divisible by 4, because 20 divided by 4 takes us straight to 5, 16 divided by 4 takes us straight to 4, you can do it in stages, just as long as you keep going until it's in its smallest, the lowest numbers possible. Okay, another quick little reminder, we're multiplying and dividing. The rules of integers apply here too. So remember, with integers, when I've got multiplication and division, if I've got the same sign, the answer is positive. Where the signs are different, the answer is negative. So -3 times -3 is 9. Because 3 times 3 is 9, the signs are the same, so the answer is positive. Whereas 3 times -3 is -9. 3 times 3 is 9, but the signs are different, so the answer is negative. Same deal with division. 3 divided by 3 is 1, signs are the same, answer is positive. Whereas -3 divided by 3, the signs are different, so the answer's -1. Really important that we remember that integer rules also apply. And just in case we have an equation that has a couple of operations in it, let's not forget BibMass applies here too. Brackets, indexes, followed by division multiplication, just moving left to right, whichever one shows up sooner. Then addition, subtraction, again working left to right, whichever one shows up sooner. So let's have a little start with multiplying fractions. We just work left to right across the numerator and left to right across the denominator. No need to find common denominators. So no need for multiples. We can just work straight across from here. So let's go. We've got 2 times -3 is -6. 5 times 7 is 35. So you notice again, just like with addition and subtraction, when I'm looking at my signs, the signs are different, so the answer is negative. I'm looking at it in terms of the numerator. So -6/35. Let's have a look at the next one. 3 times 4, 12, 8 times 5, 40. The signs are the same, so the answer is positive. And when I'm looking at 12 over 40, I can see here it's possible to simplify. They have a common factor of 4. So 4 goes into 12 3 times, and 4 goes into 40 10 times. Terrific. Again, I could have done that with 2 first and then another 2. It doesn't matter if it's a 2-stage process, provided you still get to the smallest numbers possible. Excellent. Let's have a little look with mixed numbers. Again, when we've got mixed numbers, we need to try and convert it back into an improper fraction just to make it easier to handle. So 3 times 1 is 3 plus 1. So 3 times 1 is 3 plus 1 is 4. -4/3 times 1/7 equals 1 times 4 is 4, 3 times 7 is 21. The signs are different, so the answer's negative. -4/21. But obviously remembering, improper mixed numbers need to become improper fractions. They're just too hard to deal with like that. Okay, now let's have a little look at division. So division means we keep the first fraction the same, but we change the operator from division to multiplication, and then the second fraction, we rewrite it as its reciprocal. So keep it, change that to multiplication, and flip it. So why does that work? Let's have a little look at 6 divided by 2 equals 3. So 6 divided by 2 equals 3. I'm going to make that 6 over invisible 1. We know that that's really divided by 2 over invisible 1 equals, well, we know that it's going to equal 3. But let's just have a practice doing this, keeping the first one the same, changing the sign, and then flipping the second one. So 6 over 1 times 1 over 2 equals 1 times 6 is 6, 1 times 2 is 2. And then I can cancel out and simplify. 2 goes into 2 once, 2 goes into 6 3 times, and we know that 3 over 1 is the whole number 3. So as you can see, that's a good way for remembering why it works. Go with something that you already know you know the answer to. See if you can apply the rule, and sometimes the rule ends up making a lot more sense. So now let's practice with some of these. -1/3 divided by positive 1/7. I can already tell the answer is going to be negative because the signs are different, so the answer is negative. So I'm just going to keep that in the back of my mind for a moment, but I'm going to keep this first one. This becomes multiplication, and this one becomes its reciprocal. And then left to right numerator, left to right denominator. 1 times 7 is 7. 3 times 1 is 3. The signs are different, so the answer's negative. Oh, I've got an improper fraction, so I know that what we're really talking about here is 3 into -7. 3 goes into 7. 2 times. Oh, now I put my little decimal and I add a tenths column. So I've got somewhere to put my remainder. 3 goes into 10. 3 times. Oh, but 3 times 3 is 9. So I've got my little remainder. 3 goes into 3. 3 goes into 10. 3 times. We're actually going to get to that a little bit later. I just wanted to show you that to introduce you to the idea. But for now we know that 3 goes into 7 2 times with 1/3 remaining. Oh, look at this. And we know it's got to be a negative, and we know it's got to be a negative. Signs are different, so the answer is negative. Signs are different. 3 into -7, answer's negative. So let's just have a little look here. Just a little reminder, a little sneak peek for what's coming up. And obviously that'll keep going. 3 times 3 is 9. So we've got a little remainder 1. Oh, 3. 3 times 3 is, oh gosh, we get a little remainder 1. Something to keep an eye out for our next video. So let's have a look here. We'll try this one. Keep the first, 2/7, change this to multiplication, and turn that into its reciprocal. So 2 times 9 is 18. 7 times 4 is 28. I know that both of these are divisible by 2. They have a common factor of 2. They're both even numbers. I can see that. So I get 9 over 28 divided by 2 is 14. The signs are the same, so the answer is positive. Cool. Let's just do one more with those mixed numbers, just because I went a bit pear-shaped then with division. So let's try this one again. 4 times 2 is 8, plus 1 is 9. Okay, 9 over 4. This becomes multiplication. This becomes its reciprocal. Excellent. So I get 9 times, I can do this a different way. Remember when we talked about cancelling on the diagonal? I know that 4 goes into 4 once and 4 goes into 12 3 times. So I can cancel out on the diagonal like that by finding common factors. And 9 times 3, 27. 7 times 1 is 7. Oh, again, I'm ending up with an improper fraction. And 27 divided by 7, 27 into 7 goes 3 times. 3 times 7 is 21, so that leaves 6 little sevenths left over. Cool. Now let's do a quick one with BibMaths just to see how BibMaths affects, how we can use it with fractions. So first I've got an addition, then I've got a multiplication, then okay, no brackets, no indexes. Yes, I've got division multiplication. Now remember we work left to right with division multiplication. So I'm just going to do this one first. First I'm going to go 2/5 times 1/4. That's the first part. So 2 times 1 is 2, 5 times 4 is 20. Oh, and I can simplify that. 2 goes into itself once, 2 goes into 20 10 times. Excellent. So now I've got 1/3 plus 1/10 divided by, this becomes -3 over 1. I have to turn that into an improper fraction in order to, we know that talking about invisible ones, they are improper fractions in order to make it, basically in order to make it workable. So let's have a look at what I've got here. So 1/3 plus, oh, I've got to do this bit. So keep my first one, change that to multiply, swap this to its reciprocal, and I end up getting 1 times 1 is 1, 10 times 3 is -30. All right, so now I've got 1/3 plus -1/30. And I can see already when I'm doing addition and subtraction, I need to create a common denominator, and I can see already, I just times that one by 10. So to do that, pop on a 0, pop on a 0, I don't even need an extra line. So 10 plus -1 equals 9. It's 9/30ths. 9/30ths, they've got a common factor of 3, so I can simplify that. 3 goes into 9 3 times, 3 goes into 30 10 times. So my answer is 3/10. Excellent. I hope that's helpful.